Good morning, everybody. Let's start the WHO information meeting. And today we have Dr. Sylvie Brown, the Director of the Department of Epidemic and Pandemic Preparedness and Prevention in the WHO headquarters, Geneva, to join us to open the meeting. Sylvie, please.
Thank you very much, Wenjing. Good morning, everyone. It's really a pleasure for me to be with you today and to welcome you to this very important meeting. I first want to thank you all for your tireless and continuous efforts to support influenza preparedness and response. After a period of low level of influenza activities during COVID-19 pandemic, seasonal influenza epidemics are resuming and causing severe diseases in some countries. GISRES has been a bedrock of influenza preparedness and response, and the network is agile and nimble, thus allowing the monitoring of other respiratory viruses such as SARS-CoV-2 while continuing monitoring influenza. In the recent IHR COVID-19 Emergency Committee deliberation, it was recommended that countries integrate SARS-CoV-2 into influenza surveillance to ensure a sustainable surveillance for respiratory viruses of public health importance, current and future, for instance, RSV and any novel virus X. With the support of many GISRES members and the PIP partnership contribution, WHO has been providing guidance and support to its member states to build an efficient global system of integrated surveillance and response to influenza and other respiratory viruses with epidemic and pandemic potential. Many robust influenza mechanisms, such as the vaccine composition process, are inspiring the development of similar global system and mechanism for COVID-19, and for example, the TAC-COVAC expert committee for the vaccine composition of COVID-19 vaccines. Having this collaboration between a trusted global network of laboratories and manufacturers is invaluable. Firstly, it provides a guarantee that the best vaccine possible will be made available to protect at-risk population on a seasonal basis. And secondly, this agile and fruitful partnership is essential for pandemic preparedness and response. Talking about pandemic preparedness, I would like to take the opportunity to mention the recent reports of influenza A, H5N1 outbreaks in animals and some sporadic cases in humans. The situation is concerning. Firstly, because we have high level of infection in birds and further genetic diversification and is an associated potential risk to humans. Secondly, there is an increased number of infection in wild and captive mammals. For instance, we have seen an outbreak in mink in Spain with mink-to-mink transmissions. There are also outbreaks in sea lions in Peru. Thirdly, we have seen some zoonotic infections in humans in an increasing numbers of geographies. For instance, recently, Ecuador reported the first human case in South America. Since 2003, 965 infections with H5 viruses have been reported to WHO. Unfortunately, these infections are severe, with a case fatality ratio, of 52%. Although there is an unprecedented number of deaths in wild birds and outbreaks in poultries, recently reported, especially with influenza A, H5N1 clade 2.3.4.4b, the numbers of human infections remains low, and no sustained human-to-human transmission is reported so far. We have good news on the preparedness front. First, markers for reduced susceptibility to neuraminidase and endonuclease inhibitors are rare. Secondly, candidate vaccine virus are regularly updated. We all know that one day there will be another influenza pandemic. Therefore, it is critical to watch those signals and monitor the viruses in the animal and human sector. And I would like to thank our colleagues from OFLU, FAO, and HOA to contribute to this effort to make the world a safer place. It's very important that we stay vigilant to those risks. There are, however, some challenges that I would like to highlight. There are introduction into new geographies area where the capacity to detect new viruses is variable. Human cases are often the signal for a widespread circulation in animals. These viruses are constantly evolving, in particular through reassortment. There is little to no population immunity to these viruses. The measures that are implemented in the animal sector, such as culling of poultry, may have an impact on food security. And there is a pandemic fatigue after COVID-19 and a growing mistrust in COVID-19 vaccine in some parts of the world, which can undermine other vaccine uptake, including influenza. We are all here today committed to make sure that we have tools to protect the populations against influenza and make the world safer together. The public-private partnership through the long-term collaboration via PIP framework has become a model for addressing pandemic threats. And thank you again for the partnership contribution, which enable us not only to build the necessary capacities at global and national level, but also strengthen the regional and global collaboration to address global threats. With new influenza vaccines in the pipeline, new technologies for laboratory and epidemiological surveillance, we look forward to the strengthening even further influenza and other respiratory pathogens prevention and control. The GISRES network plus its partner, including UOL, is a special asset for the world. This is a successful public health model of collaboration, trust, and excellence at such a global scale and over such a long period of time. I thank you all for your dedication, commitment, and support, and I wish you a successful meeting. Thank you.
Thank you so much, Sylvie, for giving us an overview of the current situation, not only on the seasonal influenza front, but also on the zoonotic and pandemic preparedness front. And thanks for setting the context of the work that we are going to present in this meeting. So I would also like to add my welcome to everybody. Welcome to the WHO information meeting on the WHO recommendation on the composition of influenza vaccines for use in 2023-2024. My name is Wenqing Zhang, and I'm heading the Global Influenza Program in WHO headquarters, Geneva. Before we moving on to the next agenda item, for this meeting, we have participants both on-site here as well as connected remotely. So we will not be able to give a round of self-introduction of participants, but I would like to have a round of self-introduction of WHO temporary advisors in this meeting who actually worked out the recommendation that we are going to announce later in the meeting. Let's start with Otmar.
Good morning, everybody. My name is Otmar Engelhardt. I'm from the WHO ERL at the MHRA in the UK. Many of us may know us by our previous name, NIBSC.
Good morning, everybody. I'm Nicola Lewis from the WHOCC in London.
Good morning. My name is Ziping Yi, WHO ARL from FDA USA.
Good morning. I'm Kanta Subarao from the WHOCC in Melbourne.
Good morning. I'm Dave Wentworth from the WHOCC in Atlanta, Georgia at the CDC.
Good morning. I'm Hideki Hasegawa. I'm from WHOCC Tokyo, Japan at NIAID.
Good morning, everyone. I'm Todd Davis from the WHOCC in Atlanta, CDC.
Good morning. I'm Richard Webby from the CC in Memphis, Tennessee, US.
And we also have two advisors connected remotely. I'm not sure whether Diane Wang is connected from CNIC, Beijing.
Yes, this is Diane Wang. Good morning. I'm from WCC Beijing, China.
We also have another temporary advisor from the WHOCC in Vector, Siberia, Dr. Alexander. Are you connected?
Hello, I am Alexander Ryzhikov, WHO Collaborating Center in Koltsova at Vector, Russia.
Thank you very much. Okay, so let's move on to the next agenda item is on the selection of the chair. As you know, this information meeting is always chaired by one of the WHO temporal advisors. And this time, we've invited Dr. Ziping Yi from the WHO ERL in CBER FDA to chair this information meeting. And Dr. Yi has kindly agreed. Let me ask her the floor if there's any comments or objections against this proposal. I don't hear any or don't see any hands. So Dr. Yi will be the chair for this information meeting, leading us through the discussion. I pass over to Ziping.
Hello, everyone, where you are. In past few days, we have gone through the critical information of influenza activities, antigenic and genetic information, and we summarized and made a recommendation for next flu season. And for today, we take this opportunity to present individual viruses. We start with H1N1 will be presented by Dr. Hasekawa, and H3N2 from WHO CCs in Atlanta, David Wentwell, and B viruses by Kanta Subrao from WHOCC Melbourne. And we also have information for zoonotic influenza will be presented by Todd David from WHOCC Atlanta. And after summarize those information, then Dr. Wenqin Zhang will give executive summary and announce the recommendation for next flu season. And after that, I think so we just, at the beginning of the campaign, we needed to interpret or translate our recommended the virus into the vaccine, and so that we can deliver the vaccine to the consumers. And after that, we take the coffee break, and then we have around the table discussion. And without further delay, the presentation will be H1N1 by Dr. Hasekawa.
Thank you very much. Good morning, everybody. At first, I'm going to present about the AP section and the H1N1 PDM09. Okay. Can I have the first slide, please? Okay. No change.
Christian, could you just advance the slides?
Does the thing advance?
No. Yeah. It works. Okay. This graph shows the number of specimens tested for influenza by Giesler's by week. And as you see here, the after the COVID-19 pandemic, the number of specimens decreased for a while, but it returned in the middle of the 2021 and the 2022 at the level of the pre-pandemic years. This graph shows the cumulative number of specimens processed by Giesler's it also returned in the number returned in the middle of the 2021. And in 2022, we have a sufficient number of the specimens processed. Yeah, this shows the circulation of influenza viruses by hemispheres. The left panel showing the northern hemisphere, and the right shows the southern hemisphere. Since the 1st of September 2022, the number of the influenza activity increased in October and reached at the highest level in December and declined after that. And in southern hemisphere, there's two peaks, especially in the later peak, we observe the H3N2 and the H1N1 and the B viruses as well. This shows the global circulation of influenza viruses. After COVID-19 pandemic, there are absence of influenza epidemic for a while, for 2 seasons. And it returned as pre-pandemic years in 2022, as you can see here. And the majority of the virus was AH3N2 followed by the H1N1 PDM, then B lineages. And this map shows the countries and areas and territories shared virus with WHOC. Okay, this map shows global influenza activity since September 2022 through January 2023. And the influenza activity was reported in all regions, having seen activity return to level typical of pre-COVID-19 pandemic years. During this period, influenza H1N1, H3N2, and influenza B virus circulated. The proportion of the virus circulating varied between reporting countries. Yeah, this map shows the countries and areas, territories shared virus with WHOCs. Okay, this graph is that the total viruses antigenically characterized the past 4 northern hemisphere season are shown, and the arrow suggests this reporting period. So the H3 and followed by the H1 PDM09 and B. Influenza virus genetically characterized by WHOCC since September 2022 is shown. H3N2 is predominated in this reporting period. B Yamagata has not reported for 3 years. Okay, next, move on to the H1N1 PDM09 virus. Okay. The number of H1N1 PDM09 increased from October 2022 and reached as a peak in December and declined after that. And since 1st September 2022, H1N1 PDM09 viruses have circulated and characterized from all geographic regions. And this graph shows the H1N1 PDM09 virus ungenetically characterized by WHOCs during the past 4 reporting period. This shows the antigenic reactivity of against the anti-sera raised against ferritin sera raised against the Wisconsin belong to the 5A2 cell-grown and the Victoria 2570 egg-grown 5A2 virus, and majority of the virus reacting well to this anti-sera. And the next table shows the reactivity against the ferritin sera raised against the Wisconsin 5A2 and the Victoria 2570, 582 virus, and the majority of the virus reacting to these antisera well. So that's sorry. This shows this, the reactivity against the Sydney 5 egg-grown and cell-grown, which is the Southern Hemisphere 2023 vaccine virus, and the recent viruses reacted well against this antisera. Okay. This is the map distribution of the clade and subclades of H1N1. This virus distributed globally. Among them, the H5, 5A, 2A1 distributed to Northern America and some country in South America and Europe. This shows the phylogenetic tree of the recently identified the H1N1 PDM09 viruses, and which is mainly the 5A2 viruses at the bottom, and which diversified to the subclade 5A2A and 5A2A1 in the bottom. Antigenic analysis of AH1N1 PDM09 virus is shown in this table. Antisera raised against the cell and egg grown Victoria 2570, 5A belong to the 5A2 subclade, reacted very well to the recent identified 5A2 virus and 5A2A1 virus. And the egg and cell grown in the number 7 and 8 in the very right side, the antisera ferret antisera raised against the cell and egg ground, the Victoria 4897 belongs to the 5A2A1 subclade, reacted well against the recent identified the 5A2A and 5A2A1 viruses. This is antigenic cartography map suggesting the antigenic cluster of the 5A2 viruses on the top, and the antiserum circle by using the antisera raised against the 5A2A1 virus is these cluster is included within the antiserum circles within the eightfold of homologous titer. Next, the human serology using serum panels reactivities of antibodies induced by the 5A2 A Victoria 2570 or A Wisconsin 588 H1N1 PDM09 like vaccine antigens were determined that the GMT were reduced significantly in most serum panels against the most recent H1N1 PDM09 virus of subclade 5A2 and 5A2A. Okay, in summary, H1N1 PDM09 virus have been detected in all geographic regions, and the majority of HA gene sequences belong to clade 5A1, 5A2, with 5A2 predominating. And subclade 5A2 with HA1 54Q, 186T, 189E, 224A, 259K, and 308R HA proteins. And 5A2A1, 137S, and 142R, 260E, and 277A. Some viruses share with additional HA1 substitution T216A predominating in North America and some country of South America and Europe. Ferret antisera to reference clade 5A2 H1N1 PDM09 virus. For example, the A Victoria 2570 well recognized the recently circulating subclade 5A2A and 5A2A1 virus, but poorly recognized 5A1 virus. And post-vaccination sera collected from the humans vaccinated with the Northern Hemisphere 2022-23 vaccines. GMTs were reduced significantly in most serum panels. Next slide. Sorry, there you go. post-vaccine sera collected from humans vaccinated with Northern Hemisphere 2022-23 vaccines. GMTs were reduced significantly in most serum panels against most recent H1N1 virus of subclade 5A2A and 5A2A1. Or the inhibitors, NO inhibitors of 1,361 viruses tested, the four showed resistance in genetic and or phenotypic analysis. And for endonuclease inhibitors of 1,107 viruses tested, none showed the resistance in genetic and or phenotypic analysis. Over.
Thank you, Hideki. As you all know that right after this information meeting, we will have a following teleconference among the WHOCCs, ARLs, as well as manufacturers. And if you have any specific information or questions, that will be a good opportunity to be involved. You have to raise your question because at that forum will focus on how the vaccine production will go so smoothly. And the next presentation will be focused on H3N2 and by Dr. David Winterwell from WHOCC's Atlanta.
Thanks, Yiping. All right, so the same format as Hideki just presented. Here we're looking at the AH3N2 virus detected by Gisaris. And you can see the past two seasons are the yellow line and the red line. Well, the past seasons, the yellow line and the red line. And then you can look at 2021 in the dark blue. And so you can see 2021 in weeks 42, we started to have influenza season again. But you can see in this particular season, an earlier peak and an earlier start, around week 38, 39. And that's the yellow line. And it actually started to drop before really the beginning of the next year. And you can see into week 4 coming to the left-hand side of the slide with the red line coming down significantly. And this happened. So this happened globally. It wasn't just a single country where we saw these strong peaks and then also more rapid declines. This is showing the influenza A H3N2 activity. So you might have to think back to all the pie charts that Dr. Hasegawa showed you about where H3N2 and H1N1 were co-circulating. But since this section's on H3N2, it just gives you an idea of the countries that had a lot of H3N2 activity. And the color coding, you may not be able to see the key very well, but the very light yellow is 0.1 to 5% positivity, and the more orange colors are 5 to 10%. And then as you get to the really dark orange, that's greater than 30% influenza positivity. And so you can see in North America, we had quite a bit of influenza A H3N2. There was some in South America as well. Northwestern Africa had a lot of H3N2 viruses, as well as a lot of countries in Europe and a few countries in Asia and South Asia. This slide is showing you the evolution and phylogeography of the AH3N2 gene. This compliments of our colleagues in Cambridge University. And really, it's a good high-level map. Don't get too involved in the details because I'll show you a more detailed slide on the next one. But it gives you an idea of the evolution of H3N2. And here you're looking from 2020 through all the way to 2023 with the tick marks. And those tick marks are color-coded by the map that you can see on the lower left-hand corner. And so what you can see is in 2020, we had all these viruses circulating and then they diminished quite a bit. But in the beginning of 2021, you could still see them. And so we had the evolution of what we're calling it for shorthand clade 1 and clade 2 viruses. And you can see that the clade 1 overarching viruses that continue on into 2022 are all red tick marks for the most part. So those really were localized to China. And then the clade 2 viruses show this global distribution and a lot of diversification. As you can see, the subclades forming there to the right, and they're broken up into many new subclades as we go. And as I promised, looking at the data from the past 6 months, that's on this slide. So here you're looking really at the clades that have circulated over the last 6-month time frame. And we'll start now, just to confuse everybody, at the bottom of the tree and move up the tree instead of from the top to the down. But just as this is kind of the way the virus is evolving, the clade 1s are at the bottom in that really dark purpley blue color. And the long name, for those of you keeping track of the lineage history, is 3C2A1B28.1. But for simplicity here, we're going to call those clade 1, and their derivatives are clade 1A1, which has acquired a couple of additional substitutions in the hemagglutinin at I48T and K171. One of our representative viruses there is A. Henan. I am not going to say that long name, 35, 2022. And then for the clade 2, you can see all the diversification there in the last 6 months of the clade 2. And the first thing that were described were 4 large subclades, the 2A through 2D. In the most recent 6 months, they've really come down to being the 2A and 2B viruses, and very few 2C and D viruses circulating. The 2A, as you can see, all the branch points there have further evolved. And we're seeing all the subclades I put on the right there. For example, for 2B, one of the antigens you'll see later in human serology is Florida 57, 2022. So that's a representative of that clade. And then for the 2A1, it's Maryland 2. The 2A1B is Michigan 60. The 2A3 is Alaska 01. And the 2A3A1, which is the most furthest evolved HA, is a Massachusetts 18, 2022. There's also a Thailand representative that you'll see there. And what we're seeing in all this evolution is diversification, as you can see why they're forming separate clades, but we're also seeing parallel evolution at particular sites with the same amino acid changes. And these are globally disseminated. And so the view you'll see on the next slide gives you an idea where these clades are all co-circulating. Again, this is global circulation from only a small time frame from September 2022 to February 2023. And again, that clade 1A1 really found primarily in China. And the clade 2, the high-level message is it's spread across the globe and starting to be detected in China as well. And now I know there's a lot of clades here, and maybe the colors are hard to differentiate. But if you just look at, for example, the 2B or the green, and you can see that almost everywhere where we had H3, there was quite a bit of 2B around. There was a few countries that lacked it, but what we're seeing is less geographic concentration of different clades. So it's like the world's opening back up again, and flu is mixing more across the different countries. And then the other ones that we're really seeing in this time frame are 2A1B, which you can see are the medium blue color, and the 2A3A1s, which are in basically all the 2A3s, which are the kind of the darker green. And so you can kind of look at Africa, for example. We're still seeing some geographic distribution where the 2Bs are in Southern Africa, like South Africa and other countries there. In Northwest Africa, there were more of the 2A3 viruses. Now, as I promised, sometimes the genetics gets a little complex, and it's nice to visualize where these changes of the major groups are occurring on the hemagglutinin molecule. Here we're showing you the hemagglutinin monomer. On the left, you can see Darwin 6 cell, because everything that's on this slide, all the markings that are marked up there are compared to the Darwin 6 cell virus. And what we're seeing is, if you look at that Darwin 6 cell, there's major antigenic sites are highlighted in different colors. One of the major ones is antigenic site B, which is in that peach color. Another major one is antigenic site A, which is in the green color. So those are at the head of the HA molecule. And unfortunately, I'm not going to show you a trimer because that gives you a better impression of how all this sits, but it's harder to see all the other antigenic sites. And then antigenic site E is the yellow, and antigenic site D is the light blue turquoise color, and antigenic site C is the purple color. So if we look at the Michigan 60, which is a representative of the 2A1B clade, you can see it has an I140K in antigenic site A there. It's quite close to the receptor binding site, which is circled on the molecule on the left. And then it also has changes at R99K and K267R. So not too many changes. And then the D104G is visible when you rotate it by 180 degrees. Now, if we look at Massachusetts, this has more substitutions. It's a 2A3A1. It has an E50K, G53N, N96S. And so that star there indicates that at position 94, there's an asparagine. And so this can create a putative asparagine linked glycosylation site. So that could have a large impact on antigenicity and something we want to test. And then the I140K is also present. And then if we spin it 180 degrees, you can see the I192F, which is a pretty big amino acid change up at the head in antigenic site B. And now if we move over to Florida, we're seeing some of the same changes. And, remember, this is a 2B virus now, so they split and then they started to converge at a few sites, the E50K, G53D. So we have now there the same position, but a different amino acid change from asparagine to aspartic acid. And then the I140K is present, and the S156H, that would be maybe more of a bigger change, but I wanted just to highlight here, that is almost a reversion to previous viruses. Darwin had an H156S substitution. So that's really looking a little bit more like an older clade 2 virus, not a clade 2A virus. Okay, so for antigenic analysis, this shows, again, the same format as Hideki showed, where the arrows are indicating the most recent period, September 2022 to 23, and the antigenic analysis in that reporting period. Sometimes, mainly a lot of this is to do with how many viruses you have available for your CC to analyze. But you can see a lot of us had H3s to analyze in this period. This is showing you reactivity summaries for the HI assays that are done. As you're all aware now, we conduct a lot of plaque reduction neutralization or other similar FRA type assays, and then I'll show you those next. But here's HI data, and what you can see is against with ferret antisera against the Darwin 6-like cell viruses, 80%, 87% of the viruses analyzed are considered like. They're within 2 to 4-fold of the homologous titer. And the one that's a bit lower there, CNIC, remember they had a lot of the 1A, clade 1 viruses, which are outside of this clade 2A that Darwin is. Now, if we look at the egg antigen, Darwin 9, it drops a bit to 67% like, with 33%, 8-fold or more reductions. And a similar pattern is really shown here with the virus neutralization assays. Here, all the centers are contributing more data. For example, CDC, we don't do that many HIs. We focus primarily on these virus neutralization assays. But again, now here, 97% of them are considered Darwin 6 cell-like. They're within 2 to 4-fold. And when we go, we see a little bit more distinction between the egg antigen antisera, with 44% considered like, and really moving the ones that are considered low up to 56% of the viruses tested. Now here to illustrate how that antigenic data fits together, the slide's a little off kilter. I'm sorry about that. It's some of the images have slid over, but the take home should be okay. On the left-hand side is the CDC hint data that's been merging to the right with the CRIC data. We're close collaborating centers. So if you look up on that left-hand side, you can see the circle and the egg-shaped circle that are kind of a brown mustard color, and they're circled by a black circle. Those are the Darwin 6, which is a circle, and the oval is the Darwin egg antigens, and their placement amongst all the viruses in this phylogeny. And so on the left hand, you can see the key, which is, I know, a lot of colors, but remember in the most recent period, we really have like the 2As and the 2B viruses. And so the 2As are green, so 2A3 is the darker green, and all the way to 3.1 gets to be like an aqua colored. And the 2B is kind of that salmon colored set of dots that you see on the left. And so you can see with the hint data, we are seeing like some distinguishing characteristics of each of those clades and pushing away from the 2A, which is where that the more mustard colored circles sit. I should also mention the gray dots. I know a lot of you are very familiar with cartography, so I didn't really describe it as well as I could have. But the gray dots indicate viruses that were older, and so these are only showing you viruses since February 2022. On the right, you basically see the same pattern. This is a plaque reduction neutralization test, slightly different virus neutralization test than HINT, but we're seeing a similar pattern. With some segregation, but really antigenic likeness. Each of those squares represent only a twofold change. So that's one of the ways you can just understand how they're related to each other. All of the gray dots that are covered up by the key for the second HINT are the clade 1 viruses. And so you can see clearly how easily they are distinguished. Oh, my serum circles are messy too. Okay, so we can just focus on the right-hand side because that seems to be clear. They're both very similar to each other, which is why I was showing you. We have two different CCs conducting, all the CCs actually had very similar data. And so the CC and CRIC, their Darwin 6-like virus is called Stockholm 5. And you can see its placement there. And the antisera is the black square in the middle of that circle. And the circle is drawn such that anything within that circle is within 8-fold of the homologous titer. Things outside are farther away. And so what this is really illustrating is that antisera is really still doing a pretty good job covering all of the different diversification that we're seeing amongst the 2A viruses and all of their subclades. This is now looking at two different antisera. The one on the left that's shoved over and hard to see is Florida 57 antisera, so that's clade 2B. And you can see that it's covering its group pretty well, which are the salmon-colored viruses there. But what you're kind of missing a little bit is it's not doing so well on some of the other clade viruses that were tested. And you can see that serum circle is a little tighter, so it doesn't have as broad a cross-reactivity. And remember, this is within 8-fold. So we'd really like the viruses, if you kind of in your mind's eye go in a square or two across that circle, we would like the viruses to be covered within 4-fold. And then if you look at the Thailand 8 sera, that's a 2A, 3A1 clade virus. You can see how that pushes the sera over towards those viruses that are in that group, and the 2A3s and the 2A3A1s, but starts to not cover the 2Bs as well as some of the other viruses that we've seen evolving. Now, this is looking at human post-vaccination serum analysis. This is a kind of an overly simplified way of looking at it, but it uses color coding to really illustrate how well we're seeing coverage. Just to remind everybody, these folks were immunized with Darwin 6-like virus vaccines if they were cell, or Darwin 9 vaccines if they were egg. I should have mentioned flu block as well, would be Darwin 6-like. And so what we're seeing here on the left-hand side are different panels of sera from folks vaccinated with all these antigens. And we're comparing flu cell vax and IAV4. And so the pediatric only get IAV4, so they're 6 to 35 months. And then all the way down to elderly greater than 65 years. And that bottom row, they got IAV4 high dose. And then going across the column headers, again, my text is a little bit encroaching on the labels. So the Darwin 6 is a 2A, Maryland 2 is the 2A1. The Michigan 60 is a 2A1B, AK01, that's Alaska 1, is 2A3, and then the 2A3A1, which remember had the most mutations on the hemagglutinin, is Massachusetts 18, and then the 2B representative is Florida 57, and then the 1A1 representative is that high 35. And so what you can see is if you just cast your eye down, almost every serum panel is reacting quite well. We're seeing the blue. Where we're seeing orange, what you're seeing there is that the 90% confidence interval of the geometric mean titer point estimate is starting to touch so the lower bound of that 90% confidence interval is starting to touch the 50% threshold. So the point estimate really isn't below the 50% threshold where you're seeing that light colored orange. And the other thing, I don't know if you can appreciate, but the titers there, the raw titers are pretty high, 355, 320. So even though they have reductions in their geometric mean titer, they have pretty good overall titer. Now this, I know it's busy, but it's really just meant for you to look at a high level. And so this is all the centers that conduct human serology studies as a summary. And again, the same color coding is used. And additional serum panels are included here, one from the UK, one from China. And I thought there was the one from Japan. Or is it somewhere? Yeah, it's there. Okay. Sorry, I was missing it. But I won't point them out to you. But really what you're seeing is those same subclades are arranged the same way. And we're getting good reactivity from multiple centers seeing the similar types of data. And including some immunological memory response induced by the Darwin 6 against the 1A1, which would be the most outlying antigen there. So that's a good sign. All right, and so to summarize, we saw H3N2 in many countries, areas, and territories that were reporting influenza A. This subtype predominated. We saw significant H3 activity in North America, Northwest Africa, Europe, and in some countries in Asia. With the phylogenetics of the hemagglutinin, we have our clade 1, and that's evolved into subclade 1A1, which has these additional substitutions, and these were detected primarily in China. The clade 2 shows this global dissemination. If you remember the map I showed you, it's evolved into multiple medium-sized subclades, 2A through 2D, and the 2A have further evolved into many other subclades. And in this reporting period, the 2A1B, the 2A3A, and the 2B have predominated. And so those are the merging lineages that are predominating now. Viruses expressing the clade 2 HA gene subclades are antigenically closely related and are antigenically distinct from the 1A1 viruses. So all of those clade 2 viruses you saw from the serum circles really kind of cluster together, and you saw it without the serum circles, the clustering. When we take ferret antisera to these three antigens that I've listed here, Darwin 6, the HA clade 2 viruses from multiple subclades were well recognized, which might have been hard to appreciate. I didn't show you an HI table or a virus neutralization table, but we did see some reductions amongst the clade 2B HA expressing viruses. These were around 4-fold in reactivity, so they would have been within that 8-fold circle, which might have been hard to appreciate. We did have reduced to poor activity, so depending on the center that's doing the studies, with viruses expressing clade 1A1 HAs. And with the Florida 57, the 2B, it recognized its own clade very well, but showed reductions against the other clades. And then if we're looking at a potential candidate like a 2A3A1, Thailand 8, it was a similar phenomenon where it recognized that clade virus as well, the test viruses in that clade well, but we saw more reductions in the other clades than you would with the Darwin sera. And with the human serology studies, that was really pretty very good human serology from my perspective with H3N2 viruses. That's a tough thing to do. And so most of the post-vaccination serum panels reacted well with the recent emerging clades, and even some of the older ones. Clade 2A obviously is the Darwin 6, so the homologous titers were pretty good. And the 2A1B, 2A3A1, and 2B were all pretty well recognized. And just to point out that panels from some of the younger age groups showed reduced reactivity with viruses expressing the 2B or the 1A1 viruses. And so that's pretty consistent with the ferret antisera. With the antiviral susceptibility of the 2,686 H3N2 viruses collected from 1 September 2022 till now, none of them showed phenotypic evidence or genetic or phenotypic evidence of reduced inhibition to neuraminidase inhibitors. And the same can be said for the 2,429 H3N2 viruses tested for genetic and phenotypic susceptibility to baloxavir marboxyl.
Thank you, David. Now we move on. B viruses will be presented by Dr. Kanta Subrov from WHOCC Melbourne. Kanta.
Thank you, Ziping. So I'm going to talk about influenza B viruses, as you've heard, and we are going to follow a very similar pattern in terms of the slides that you'll see. And so these are the data on global circulation of influenza B viruses. You can see that there was really not much happening in 2021, and influenza B sort of started returning in 2022, and we've had some activity in 2023 as well. A lot of the orange lines are influenza B viruses for which lineage was not determined, and the aqua line is B Victoria lineage. So this is now looking at the number of influenza B viruses detected by GISRIS, showing it by week. And again, the yellow line is 2022, and the red line at the beginning of 2020 is the beginning of 2023. So we had some influenza B activity kind of simmering along, much lower than the influenza A viruses, representing about just under 6% of the viruses that were characterized by the centers. So looking at the data from September of 2022 to January, of the influenza B viruses that were characterized for lineage, we have identified no B Yamagata lineage viruses. 18% of those that were characterized, 18% were lineage typed as B Victoria, and there's a large percentage of them that have not been lineage identified. So you've seen this sort of activity map from the others, and you could see that there was influenza B activity in different parts of the world. Again, the color coding represents the countries that have more reported activity. The intensity demonstrates that. So you can see that we had some pretty intense activity in part of Southeast Asia, and certainly reports from the rest of the world as well. So I'm going to talk to you about BVIC lineage viruses first. Again, this is a megatree courtesy of our colleagues from Cambridge. And similar to what David explained to you, the vaccine strain is listed. The previous vaccine strain is listed, and that's B Austria 1359417 2021. And the figure at the bottom left is the world map that shows you the color coding. And this is really just to show you how over the past many years, we've primarily seen influenza B-Vic viruses with a triple deletion, triple amino acid deletion from amino acids 162 to 164. And that group, which was called 1A3, has diversified. And the predominant viruses circulating in this past period have been called 1A3A2, so we'll abbreviate it to 3.2, with amino acid substitutions listed here. So if we look now at a more detailed phylogenetic tree, and this is from the WHOCC in Atlanta, it's really to show you that the vast majority of the viruses that they characterized fell into this 3A2 group. There are a smattering at the very bottom of some viruses from Central and South America that still belong to the older lineage, the 1A3, that was sort of an example of which is the B. Washington 2019 virus. If we look now at the clade diversity and how it has changed over the years, the data on the left are data from February of last year to August, and on the right are September 2022 to present. And this is based on when we have HA sequence available. And you can see in these pie charts, it may be hard for you to spot, but you're looking, the older lineage viruses are the darker blue. And you can see that there's been a gradual reduction of that was seen earlier last year in Europe, for instance, and now it's really only seen, I wish I had a pointer, but now it's really only seen in Central and North America and Central America. So again, this is another way to visualize this clade diversity as it gradually shifts over from September of 2021 to January 22. And you could see that the V1A.3 and the 3A1 viruses have gradually reduced in this period. So we've characterized a total of 278 viruses in the influenza B viruses in this period. And that, if you remember from the other slides, it's the little purple bar for each of the centers. We've used post-infection ferret antisera raised against the B. Austria cell on the left and B. Austria egg propagated virus on the right. And each of the centers have characterized viruses, and 99% of viruses that have been characterized with post-infection ferret antisera have reacted well with the cell and egg-grown Austria viruses. So looking at antigenic cartography, and here, here as well are the data that we've been provided by the University of Cambridge. And you're looking at the B Austria cell and egg in the middle of the kind of the green range of circles, and that's from an HI test done from the WHOCC in London on the left and the WHOCC from Melbourne on the right. And you could see that the viruses that have been characterized in this period are cluster around the B Austria egg and cell propagated viruses. And this is now looking at the serum circles. Again, these are serum circles where the circles cover the viruses within 8-fold. And you could see that the viruses are well covered by the antisera raised against the cell and egg-grown viruses. These are data from the WHOCC in London, serum using sera raised against the cell-grown virus on the left and the egg-grown virus on the right. Here's one example of an HI table, and it's an example from our center in Australia. I've tried to box together at the center the ferret antisera raised against the cell-grown and the egg-grown viruses. And it's a heat map, so you can take away from this that all of the viruses, all of the test antigens were well covered by antisera raised against both the cell and the egg-grown viruses. So you've had a great introduction of the post-vaccination human serology, so I won't belabor the details of how it's done. We had many panels indicated on the left from different age groups. Everybody, all of the vaccinees had received the B Austria vaccines in different forms. And it's a heat map, so all of the blue indicates that those the antigens from the different subclades are well covered by sera from vaccinees who received the Austria virus. On the very far right are the older viruses that belong to the 1A3. And you could see that they are not as well covered by the antisera raised against the Austria virus. In terms of antivirals, of 472 B-Vic lineage viruses collected since September of 2022, we've detected no evidence of reduced inhibition by neuraminidase inhibitors, and of 374 B-Vic lineage viruses examined for sensitivity to baloxavir marboxyl, we detected no evidence of reduced susceptibility. So I'm sure there are going to be questions about what about BEM? So we have had no confirmed detections of circulating, naturally occurring B Yamagata lineage viruses after March 2020, including in this period. Recent reports of B Yamagata detections could not be confirmed as naturally occurring B Yamagata lineage viruses, or were identified as the B Yamagata lineage component of live attenuated vaccines. However, we cannot yet be confident that B Yamagata lineage viruses are extinct. GISRIS, the WHO GISRIS will continue to actively conduct targeted surveillance for influenza B Yamagata lineage viruses. So the overall summary, we've only had influenza B Vic lineage viruses available for analysis. The phylogenetics of the B Victoria lineage viruses indicate that they all belong to clade 1A3. And the subclade 1A3A viruses have some additional amino acid substitutions at N150K, G184E, and N197D, and R279K in the HA1. This clade had previously diversified into two main subclades that we call 1A3A1 and 3A2. We have not seen any viruses in the 3A1 subclade in this period, but we have seen viruses from the 3A2 subclade, And there are some further additional amino acid substitutions that are appearing in these groups. The majority of these viruses have an additional substitution at 197. A small number of viruses derived from the older lineage 1A3 continue to be detected in North and Central America, and they've evolved substitutions T73 and N233K. Post-infection ferret anisera raised against the B. austria cell and egg-grown viruses inhibited the majority of recently circulating viruses well. The small number of 1A3 viruses detected in North and Central America were recognized well by anisera raised against the B. Washington 1A3 virus, but were poorly recognized by ferret anisera raised against the B. austria-like viruses. Human serology studies using serum panels from recipients of the Northern Hemisphere 2022-2023 vaccines that contained the B. austria-like viruses were well in all the recently representative BVIC lineage viruses were well covered by all the serum panels, but there were significant reductions in GMTs with most serum panels against those viruses from clade 1A3. None of the viruses analyzed showed reduced susceptibility to neuraminidase or endonuclease inhibitors. Thank you.
Thank you, Kanta. Great presentation. Your extra slide regarding the Yamagata will answer some people's questions. I'm sure we have opportunity to discuss this in a different format. The next presentation will be zoonotic influenza viruses. Will be presented by Dr. Todd David from WOCC Atlanta.
Thank you, Ziping. So I'll start with just an update on the number of zoonotic infections that were detected during this 6-month reporting period, with a total of 24. As you can see, there remains consistent detection of these viruses throughout the years. From 2021 to 2022 and now into 2023, we see those gradual increases relative to some of the earlier years. So remain quite vigilant to look for human infections with the many zoonotic subtypes that circulate in animals. There have been 9 cases of highly pathogenic H5 viruses detected during the reporting period, 8 cases of H9N2, 5 cases of AH1 variant or swine origin influenza viruses, and 2 cases of H3 variant viruses. And I'll go into some detail on each of the subtypes characterized. To begin with H5, this is a map shared by our colleagues at the OFLU network, describing the geographic distribution of highly pathogenic H5 viruses around the world and reported to the WOHA network. The bottom of the screen shows the temporal distribution. As you can see, in sort of the beginning of December, as is expected from year to year, we typically see an increase in highly pathogenic strains detected and reported due to the circulation of those viruses and their appearance in migratory birds that are moving from northern climates to southern climates during this time period. And so we typically do see a slight increase during the colder months throughout the northern hemisphere. As Dr. Brienne mentioned, one of the intriguing findings from this reporting period is now detection of high-path H5 viruses into Mexico, Central America, as well as South America. And also the sporadic detections, but increasing detections in more than 12 different species of mammals around the world. And that includes even some of the recent detections, such as the sea lions that were detected in an outbreak in Peru. So again, remaining quite vigilant, both with veterinary health colleagues as well as public health colleagues to track the ongoing circulation and new incursions of this virus into new regions around the world. Looking at the activity in humans, as I said, there have been 9 cases reported during this reporting period. Of these, viruses belong to both the H5N1 subtype, as well as 3 cases of H5N6 that were reported in China in this reporting period. And of those cases where sequence data has been obtained, all of them fall into the clade 2344B group of viruses, which we'll talk a little bit more in detail But a case was reported in Vietnam. Again, as Dr. Brian mentioned, the first case detected in South America was reported from Ecuador, from a case that had illness onset in December of 2022. 2 cases that were asymptomatic, but also reported from Spain, from poultry workers, as well as 3 cases of H5N1 from China and 3 from H5N6 in China. I think the other thing I'll mention is that while the outcome of each of these cases hasn't been fully resolved through the IHR reporting system, many of these have recovered from infection, but I'll note that some of these have also been severe, critically ill individuals, and several have resulted in fatal infections as well. Looking at the phylogeny of the clade 2344B viruses, another feature of this reporting period is, again, as these viruses have expanded into new geographical regions, we've also seen some genetic clustering of these viruses depending on where primarily migratory birds have been limited by their flyways. And so what we've seen is that in North America, Central and South America, these viruses fall into a specific subcluster of the clade 2344Bs, as you can see from the top of the screen. The case from Ecuador, as well as a previous case reported from the United States and Colorado, fall into this group of viruses. And most of the mammalian cases detected in both the US, Canada, as well as Central and South America also fall into this group. Europe also has a group of viruses that are maintained among migratory birds, as well as some poultry outbreaks in those countries. The cases from Spain are shown in the phylogenetic tree as well. In Asia, also in particular in China, Vietnam, Laos, and a few other countries also have a variety of 2344Bs that are genetically a bit different from what has been detected in other regions of the world. And finally, I'll mention that in Africa, there also remain some circulating viruses. The previous VCM, we did recommend a strain called the A. Ghana 2021 that's being developed as a CVV, and this has proven important, which I'll talk about in a minute, but primarily just to say that the CVV it remains quite cross-reactive with viruses from Africa, as well as those that have been detected in Europe, as well as in Asia. But as these viruses have begun to cluster genetically based on their geographic region, we have noticed that there have been accumulation of amino acid substitutions, specifically in the HA protein of many of these viruses. And as you can see from this HI test, we have developed ferret antisera to several of the candidate vaccine viruses that have been developed by WHO collaborating centers and ERLs. One of those is called ID-CDC RG71A, or the Astrakhan 2020-like CVV. And this one has been used and has shown effective at cross-reacting with many of the circulating strains around the world. But as viruses have, again, accumulated those mutations in North American and Central and South American viruses, we have noticed a subtle reduction in the cross-reactive titers of viruses with this ferret antisera generated to the Astrakhan CVV. And while it's not homogeneous across all of the viruses tested, we have noticed that about half of the strains tested from the United States are beginning to show a 4-fold reduction in heterologous titers, and a few that have even dipped below 8-fold relative to that ferret antisera. And so based on this finding, we've also generated ferret antisera to circulating virus from the US, one of the first viruses detected in the US in 2021, called the American Widgeon South Carolina 2021 strain. And as you can see from the left-hand side of this HI test, the cross-reactive titers are regained with ferret antisera generated to the American Widgeon. And so we see viruses now that only have as much as a 2-fold reduction relative to that ferret antiserum titer. And so based on this data, we've decided to recommend the development of a new CVV antigenically like the American Widgeon South Carolina 2021. Moving on to H9N2 viruses. There have been 8 cases reported from China during this reported period. Most of these resulted in mild illness. One was reported as severe. And with the exception of the one severe case, all of these cases did recover from infection, and following that case in China to look at the final outcome of that infection. H9N2 really has remained relatively genetically homogeneous in China. These viruses belong to the Y280 group of viruses, and data from China CDC does show that the CVVs developed against H9N2 viruses does remain cross-reactive, albeit with some viruses showing some reduced titers. So again, following those viruses closely and generating some additional reagents to further characterize the H9N2 viruses detected in humans in China as well as in poultry in many regions of the world. The influenza A, H1N1 variant viruses, as well as some H1N2 variants, were also detected in this reporting period. This is a map also from OFLU colleagues showing the distribution, both on a temporal scale, but also at a geographic level. Looking at, again, the steady detection of these viruses throughout the reporting period and the ongoing circulation of multiple genetic groups shown on the right-hand side of this slide. As you can see, those viruses detected in the United States as well as Canada, and quite a few viruses detected in European swine populations do show the extent of this genetic diversity that we see in the H1 viruses at the global level. There were 5 cases reported, 1 from Brazil, 2 from China, an H1N2 variant detected in the Netherlands, and 1 H1N2 variant detected in China. These all resulted in relatively mild infections, and these cases have recovered from infection. Just again to point out the geographic and the clade distribution of these viruses, again, they do tend to fall into specific geographic clusters, depending on where swine influenza viruses are circulating. The virus that was detected in Taiwan that caused a human case, that virus falls into a group called the 1C2.5s. This group does not have a candidate vaccine virus developed against it, but we're doing some additional antigenic characterization of that virus now so that we learn more about the antigenic distribution of that particular group, as well as the 1C2.6s, which is a newly emerging clade that was recently identified based on the circulation of swine influenza viruses in parts of Europe. So keeping a close eye on a few of the H1 clades that do not currently have candidate vaccine viruses developed. And finally, the influenza A H3 variant viruses. These viruses also remain a steady state of detections across the reporting period, as you can see at the bottom of the screen. Like the H1s, they also fall into multiple genetic groups shown on the right-hand panel. And as you can see from the detections in Canada, the United States, as well as in Europe, we do see ongoing circulation of these clades across the globe, with many of the viruses from the United States falling into a group called the 2010.1 clade, which is a swine influenza virus that was derived from human seasonal viruses circulating in the mid-2010s that have remained persistent in the swine population in the US. And of the 2 cases that were reported from the United States, one from Michigan, one from New Mexico, these did belong to the 2010.1 lineage of the H3N2 variants. Both of these cases resulted in mild illness, and both cases recovered. And that's the summary of our zoonotic update for this reporting period. Yeah, thank you.
Thank you, Todd. Now we move on to Wenqing to announce the recommendation of the composition for next season.
Thank you so much, Ziping. So I'm going to summarize briefly the work already presented by our Clubbeating Center directors. Let me start with the method of the work. Of course, we all know that the work we presented today is all based on the year-round surveillance conducted by the Global Influenza Surveillance and Response System, GISRS. So let me update you the figures of the members of the GISRIS. This network currently comprising 159 institutions in 127 countries, territories, and areas. And this network's function, of course, is supported strongly by its hosting countries and international agencies, but also partners, for example, OIE, the World Organization for Animal Health, and FAO, or FLU, as well as institutions like GISED. In the past 4 days, WHO organized a consultation to review, to analyze, and to make a conclusion of the recommendation that will be announced. This meeting was a hybrid meeting of in-person and virtual participation. It was chaired by Dr. Kanta Subbarao, the director of the WHOCC in Video Melbourne. The meeting had 9 advisors. At the very beginning of the meeting, the interest declared by these experts were disclosed to all meeting participants. And as you can see from the photo, we have 2 advisors attended the meeting remotely. In addition, we have 39 observers from National Influenza Centers, CCs, EILs, other GISRIS laboratories, academia, and we also have observers from WAR, FAO, and AFLU. Experts from the WHO's flu program in regional offices and HQ also attended this meeting. So let me summarize briefly the situation here first. Since September last year, I should start with influenza surveillance, which was disrupted at the early stages of the COVID-19 pandemic, has recovered in most countries. And many countries, they are using multiplex to address surveillance needs of both influenza and SARS-CoV-2 at the same time. So now let's come to the actual situation of the activity between September last year to February this year. Influenza activity reported from all regions. And in many countries, influenza activity returned to levels typical of pre-COVID pandemic influenza seasons. H1N1 PDM of 9, H3N2 and B viruses circulated in varying proportions, with influenza A virus detections outnumbered those of influenza B virus detections in most countries. And H3N2 viruses predominated in many countries, while H1N1 PDM of 9 viruses predominated in some countries. Influenza B viruses were detected in many countries, but predominated only in a few countries. Here, there's a list of the human infection of zoonotic influenza during this specific period from 20 September last year to 20 February this year. The point I would like to make is that they are sporadic human infections. There's no sustained human-to-human transmission, and most of the cases had the known exposure history to poultry or to swine, to animals. So let's zoom into the H1N1 first. H1N1 PDM of 9 viruses circulated in all geographical regions during this period. Genetically, HA of these circulating viruses belonged to 2 clades, 5A1 and 5A2, with a majority in 5A2. 5A2 evolved and formed subclade 5A2A, which further evolved and formed subclade 5A2A1. 5A2A and 5A2A1 co-circulated with regional differences in proportions. 5A2A1 predominated in North America and many countries in South America and Europe. Antigenically, ferret antisera raised against egg-propagated A. Victoria 2570-like and cell culture-propagated A. Wisconsin 588-like, which, as you know, they are the vaccine composition for Northern Hemisphere 2022-2023, recognized well 5A2A1 and 5A2A1A viruses, but not 5A1 viruses. Ferret antisera raised against egg-propagated A Victoria 4897 and cell culture-propagated A Wisconsin 67, which are 5A2A1 viruses, recognized well 5A2A and 5A2A1 viruses well. In human serology studies using the Northern Hemisphere 2022-2023 post-vaccination human antisera, post-vaccination GMT, geometric mean titer was significantly reduced. In most serosum panels against most recent viruses or subclades, 5A2A, 5A2A1, and 5A1, compared to the Northern Hemisphere 2022-2023 vaccine viruses which belong to 5A2 subclade. Let's zoom into H3N2 viruses. H3N2 viruses predominated in many countries since September last year. Genetically, viruses since September last year belong to two major clade, clade 1, which evolved into subclade 1A1, which were detected primarily in China, and clade 2, which evolved into multiple clades with diversities geographically. And globally, 2B, 2A3A1, and 2A1B viruses predominated. Antigenically, ferret antisera raised against cell culture-propagated A-Darwin-6-like or egg-propagated A-Darwin-9-like viruses, which are the vaccine composition for Northern Hemisphere 22-23 and Southern Hemisphere 23, inhibited well 2A, including emerging subclades viruses, but less well 2B viruses. 1A1 viruses recognized well by ferret antisera raised against cell-propagated and Cambodia virus, which is the Northern Hemisphere 2021-2022 like virus, but generally recognized poorly by ferret antisera raised against clade 2A viruses. In human serology studies using the Northern Hemisphere 2022-2023 post-vaccination human sera, the GMT titers in HI and virus neutralization assays of antibody against majority of cell culture-propagated 2A, including its emergent subclades, 2B and 1A1 viruses, were not significantly reduced compared to those against the vaccine virus A-Darwin-6. With regard to B, since September 2022, the B virus detection counts for 5.8% of the viruses detected globally. All viruses detected belonged to B Victoria lineage virus, and there's no confirmed detection of B Yamagata lineage viruses after March 2020. So genetically, all B Victoria lineage viruses since September last year belonged to clade 1A3, which has a triple amino acid deletion in HA1 with 1A3A subclade viruses predominant. 3A viruses further diversified into two main subgroups, 3A1 and 3A2, with 3A2 viruses predominated in Africa, Asia, Europe, North America, and Oceania. Antigenically, ferret antisera raised against A Austria 1359417 like viruses, which is the vaccine composition for Northern Hemisphere, the past Northern Hemisphere and the Southern Hemisphere 2023, recognize well 3A2 viruses, but not 1A3 viruses. B Washington 2 like virus, which is the vaccine composition for Northern Hemisphere 21-22, recognized well 1A3 viruses, but not 3A2 viruses. In human serology studies, post-vaccination GMT in HI assays against recent 3A2 viruses were not significantly reduced compared to those of egg or cell propagated B. Brisbane-like viruses. But there were observation of significant reduction detected in some panels for 1A3 viruses. Serology studies were not done for B. Yamagata lineage viruses because there's no B. Yamagata virus detected since basically since March 2020. So based on this analysis, it is recommended vaccines for use in the 2023-24 Northern Hemisphere influenza season containing the following for trivalent egg-based vaccines: an A. Victoria 4897 2022-like virus, an A. Darwin 9 2021-like virus, and an B. Austria 1359417 2021, which is a B. Victoria lineage-like virus. For trivalent cell or recombinant based vaccines to contain an A. Wisconsin 67 2022 like virus, A. Darwin 6 like virus, and B. Brisbane 1359417 2021 like virus. For quadrivalent egg or cell culture-based or recombinant-based vaccines, in addition to the above three components, to include a B. Phuket, which is a B. Yamagata lineage viruses. So those technical reports, FAQ, and CVVs are live on the WHO's website. Just to mention that today, from 1 to 2, we will hold a press briefing, and there will also be YouTube Live available to brief the outcome of the vaccine composition as well as the situation of the current situation of avian influenza and influenza pandemic preparedness. And next week, 1st March, we'll have a webinar. We'll also introduce how the work was done as well as the situation of influenza. Let me stop here and hand back to our chair.
Thank you, Wenqing. I don't know if maybe if you guys are surprised or not. So I think they always have a different views. Anyway, I think after this recommendation, local and regional regulatory agencies will adapt the WHO recommendation. And the next presentation will be Dr. Engelhardt from WHO ERL London to present vaccine candidate viruses that we used for inactivate and or split the subunit vaccines and also reagents for the vaccine sterilization.
Thank you, Siping. So I'll give you a very brief tour through the landscape of available CVVs and potency testing reagents. Let's start with candidate vaccine viruses, and I assume of greatest interest to everybody here will be the available CVVs for the newly recommended H1N1 PDM09 viruses. So for egg-based vaccines, we're talking about a Victoria 4897 2022-like virus. And indeed, there's a fully tested CVV available. That's IVR 238. And that is derived from the wild-type Victoria 4897 virus. For cell-based vaccines, as well as recombinant vaccines, the recommendation is for an A. Wisconsin 67 2022-like virus. And you also have the accession number here for those who work based on genetic information. And two CVVs are available from the US CDC, West Virginia 30 and Georgia 12, both from 2022. Now we move to H3N2 for egg-based vaccines. As you know, A. Darwin 9 2021 is the recommended like strain, and a number of CVVs is available. I'm not going to read them out. I think most of you will be familiar with these, and they are also listed on the WHO website. For the egg-based, there's a second page. Yeah, there's lots of CVVs available for the egg-based Darwin-9 recommendation. For the cell-based vaccines, where the recommendation is for Darwin-6 2021-like virus, the virus Darwin-11 2021 is available from Vidril in Australia. Now moving to B Victoria, again, B Austria 1359-417 2021 is not a new recommendation, and therefore CVVs have been available for some time, which are listed here. And for cell-based vaccines, there are two CVVs fully tested available, one from the US CDC and one from Vidril in Australia. And the P. Phuket 3073 2013 virus has been recommended for quite a number of years, and therefore a lot of CVVs are available. And I assume most of those people who need these CVVs will have some of these in their freezers. And 3 cell-derived CVVs are also available to implement the P. Phuket recommendation for those who produce a quadrivalent vaccine this season. Now, quickly talking about the potency testing reagents. Obviously, for the newly recommended strains for the H1N1 PDM09 component, reagents are not yet available. For ERLs in Japan, in Australia, in the US and in the UK, will work very hard in the next few weeks and months to make these reagents and make them available to everybody. In contrast, for H3N2, reagents are already available. They are listed here, and I'm not going to read them out, but you can see that reagents are available for egg-derived vaccines, as well as for cell-derived vaccines and recombinant HA-based vaccines. And the same is true for the B Victoria component, where reagents are available for egg-based vaccines, for cell-based and recombinant vaccines. And then again, for pre-Phuket, same situation. So if this was too fast for you, you can find all the information on the WHO website. And I'll hand back to the chair.
Thank you, Althama. I think so we are pretty good, and for the time, I think we can take like 10 to 15 minutes break. Because of quite a few people online, I don't want to change the time, and we don't have a lot of people here, so we can take a quick break. We come back 11:45 Geneva time.